Okay, hi guys. So in this lecture, we'll be discussing some more examples on the oxidation. We'll be seeing some more oxidizing agents like K1O4, HIO4. Okay, so let's get started with the first example. Okay, so let's say we have uh, this compound and we react cold alkaline KMNO4 with this, so we get product A, and after that we react it with HIO4, we get product B. So what are A and B? A and B are simply when we react any alkene with KMNO4, what actually happens is on both sides of the bond OH gets attached. Okay, so we get something like this product. Okay, and this product on reacting with HIO4, what will we get? Again, on both sides of the bond we'll be getting OH, and this bond will be cleaved. Okay, so what we'll be getting? We'll be getting something like a ketone, and we'll be getting HCHO. Okay, let's look at another example. Here we have something like this. Okay, and we get OH attached here. Okay, again if we pass it in presence of HIO4, what will we be getting? Again this bond will be cleaved, and on both sides of the bond OH will be getting attached to the carbon atom, and as a result we'll be getting something like a symmetrical ketone. Okay, let's look at another example wherein we have something like this. Okay, and we have CH2OH. Okay, now again we will cleave this bond, and on the both side of the bond we'll be getting attacks with OH, so we'll be getting something like this. Will be obviously CO2 would be released. Okay, and then in this carbon, if we talk about this, then we'll be getting the, so ideally this is all we should be getting. CO2 plus we'll be getting HCHO. Okay, so if you just remember from previous lectures that we made a good note that HCHO or HCO2H is the only compound which was getting actually made after we reacted with HIO4. Okay, I'll just explain it once more in a way that when we were talking about the oxidizing reagents, okay, just like LiLH4 or HIO4. Okay, so what actually we were seeing is that this compound actually was resembling its structure with the formyl group. Okay, that's why we were saying that it's very easy to react this compound in presence of HIO4 and form CO2 gas. Okay, because of its formyl like structure. But in this case, when we talk about this structure, we will have something like R group attached here. Okay, and it is not a formyl like structure, which is something like, okay, so this is nowhere related to the formyl like structure. Okay, so in this case the CO2 formation would be not getting in the product side. Okay, so only CO2 formation would be there in case of when we will have a formic acid, not with acetic acid or number of carbons greater than 2 or equal to 2. Okay, in that case CO2 won't be forming. Okay, so we won't be getting these products that we should have gotten ideally. Okay, as we discussed earlier, and the reason is this is a not a formyl like carboxylic acid, as it contains more than 2 or equal to 2 carbon atoms. Okay, hence the reaction will not take place. Okay, let's understand fourth example, where we have a compound which on reacting with HIO4 forms this compound. Okay, which and obviously we get this compound. Okay, so what would be the A compound? So A compound will be something like, we are also getting this compound, right? So it should be something like definitely one OH. Okay, let's start from the bottom up. So definitely one OH would be there on this ring, because this would be, and at least one carbon atom would also be there, because this bond then can be cleaved to form at least one compound like this. Okay, and on second compound, or on second carbon, which is this, it should be having at least two methyl groups attached to it, and it should also have OH, so that on cleaving you can attach two OH on both side of the bond. Hence this would be product A. Okay, so let's discuss another example where we have something like A product reacting with again HIO4 and forming 2HCHO plus something like HCO2H. Okay, so what would be the product A? Product A would be nothing. We also saw in some of the cases that if we have something like HOH here, okay, so and another OH, H, and HOH here, okay, and various other possible stereoisomers for this possible compound, or different configurations R and S would be there. So we are not talking about them, we are just talking about one of those compounds which can result into this. Okay, so it may be possible that the product A has multiple answers, and it can be asked in one answers multiple questions, means multiple answers for a one question type of questions that are generally asked in J level examinations. Okay, so how did we arrive at this? You have to just make a guess. Okay, and then you have to verify that guess whether on attaching OH on both the sides of the bond while cleaving the bond forms the same compound or not. So this carbon and this carbon actually forms 2 moles of HCHO, and this actually forms the carboxylic acid. Okay, let's look into another example where we have something like E compound on reacting with again 3 moles of HIO4, and we get something like 2 HCHO and HCO2H and the evolution of CO2 gas. Okay, so what would be the compound A? Obviously it would be having 4 carbon atoms in a straight chain. Why? We are using 3 moles of HIO4, so this hint is enough. Okay, so what will be getting at each of the carbon atoms? So we are getting 2 moles of HCHO, that should be the terminal carbon atoms. Okay, problem is solved. You can have CH2. Okay, so for these 2 carbons, 2 moles of HCHO is confirmed. Now CO2 gas is also getting released from the reaction. So one of the carbon atoms must be having C double bond O, or originally in the compound. Okay, because if it were not there, then it is not possible to release CO2 gas. Okay, so what will happen here is, this bond breaks, we will get OH and OH on both the sides, and if this bond breaks again, we will get OH and OH on both the sides. So what will happen is, this carbon atom will be getting something like this substituents, and then CO2 gas will be evolving, as dehydration can occur easily in this compound, leading to the release of CO2 gas. Okay, so this is confirmed, and then we have 1 mole of CO2H. So this is easy, because it should have 1 H and on both the sides. If this carbon atom actually gets 3 OH, then it is sufficient for it to convert itself into carboxylic acid. Hence this is product A. Okay, so now let us move on to next topic, interesting one called esterification. Okay, so here we have that the formation of ester is known as esterification. Simple definition. Okay, next is obviously when we react the acid with a alcohol group in presence of acidic medium, let's say, then what actually happens is we get a formation of a compound something like this, which is called ester, and we have a water molecule also in place, and this actually has a fruity smell. Okay, so why do I always tell you about the what is the order of a particular product formed? Because many a times in comprehension type questions, you'll face some problems having mentioning the color or order or any other property, physical property or chemical property of a given compound. Hence it would be easy for you to relate that okay, one of the many pieces of the puzzle is solved, as you know the color, order or any other chemical or physical property of that substance. So it would be easier for you to relate by that and get to the answer very fast. Okay, so this is a small trick which many exam level authorities play on students, so you should be very aware of these things. Hence I'd always tell you about anything which I find relevant after seeing the various examination papers every year. Okay, so one thing to note here is if the reaction goes in forward direction, then it's called esterification. Forward direction is called esterification, and if it comes in backward direction, then obviously it's called hydrolysis of ester. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the esterification and hydrolysis of ester, obviously. So till then, good luck and goodbye.